Okay, so let's discuss INMO 2025 P3. So this was a construction problem. It says we have a tool splitter which can do the following things. One is, given three non-collinear marked points A, B, and C, we can construct the line which forms the interior bisector of angle ABC. So let's understand the question. It says, given 3 points A, B, and C, which are known to be non-collinear, what we can do is we can construct the bisector of angle ABC. We can construct the bisector of angle ABC. So this is the first statement. Note that these lines AB and BC are not marked. So we can construct the angle bisector. Suppose in this video I will be denoting the angle bisectors as LABC, like this. Given 3 points, we can construct the angle bisector of angle ABC. And this is interior angle bisector. And this lines AB and BC are not given. Second thing that it says is basically it can mark the intersection point of two already marked non-parallel lines. So if we have two non-parallel lines, we can mark their intersection point. This is the second part. This is the second thing that we can do with the tool. And what are we supposed to do? We need to construct the center of a circle which passes through three given non-collinear marked points A, B, and C. Basically, we are given three marked points A, B, and C. We need to construct the circumcenter of triangle ABC. This is what the question says. So let's start the problem. Given 3 points, we can draw the angle bisector. This is the first thing. The second thing is, given two lines, we can mark the intersection. And we are given 3 points A, B, and C. We need to construct the circumcenter of triangle ABC. Now, the thing is, in this, let's try to play around. One important thing is that the lines AB, BC, and CA are not given. So let's see. What we can do is, let's just play around. The tool can only do these two tasks. One is it can draw the interior bisector, another is marking the intersection point of non-parallel lines. We are given only 3 points, so we can only do the operation 1. We cannot do, for now we cannot do anything in operation 2. So let's just, what the simplest thing that we can do is just construct the angle bisector of angle ABC. This is the first thing that we can do. Second thing is we can construct the bisector of angle ACB. So this is angle bisector of angle ABC, and this is the bisector of angle ACB. And they meet at some point I. What you know is this is the incenter of triangle ABC. So here we have our first lemma. Basically, given 3 points A, B, and C, we can mark the incenter. So this is our first lemma. Now let's try to think. Okay, this is the most simplest thing that we can do. And see, in the problem, we want to construct the circumcenter, not the incenter. So we somehow want to go from incenter to circumcenter. So basically what we can do is this tool can only construct angle bisectors, and we want somehow the circumcenter. Basically we want some relation between angle bisectors and circles and circumcircle. So basically we want some relation between angle bisectors and circumcircle. So now we are stuck. Let's just try to play around. Let's just try to see some configuration. Okay, let's try to see. We have this 3 points A, B, and C. These are not marked. Let's just see what all we can get in the diagram. Suppose this circle is there, suppose, and we want the center of this circle. What we can do is we have this incenter of triangle ABC. we want the circumcenter of this. So incenter is basically the intersection of the angle bisectors. Basically, the whole problem is in this diagram, because we want to somehow get this point O from the given points A, B, and C. Now, what all things are nice in this diagram? Basically, in this, what nice things that you can see is basically this point. This point is nice because AX is the bisector of angle BAC. Now we are just exploring the diagram, this diagram, because we want somehow a relation between angle bisectors and circumcircles. AX is the bisector of angle BAC. So what you know is the arcs BX and XC subtend equal angle at A. This means arc BX and XC are equal. What does this mean? This means BX and XC are equal. Basically, X is the midpoint of arc BC. And what are nice things that we know is we have this information that BX is equal to XC. We are just exploring the diagram. BX is equal to XC. This is an isosceles triangle. And what is the, like, do you have something nice in isosceles triangle about angle bisectors? Suppose you have 3 points X, Y, and Z, and this X, Y, and XZ are known to be equal. Basically, this XYZ triangle is given to be isosceles. What nice thing that you know? Basically, if you construct the bisector of angle YXZ, this is basically the side bisector. This is basically the side bisector of YZ. So this is actually nice because from something like angle bisector, we got something related to side bisectors. And you all know is that bisectors, the intersection of side bisectors give us the circumcenter. So let's just try to play with this idea. If we have this points, let's see, if we have this points A, B, and C, what we can do is we can construct the bisector of angle BAC. We can get the incenter by constructing another angle bisector. And now what we know is we have explored this diagram. We have this point X. What all information that we have is, what we know is BX is equal to XC, and the angle bisector of angle BXC is the side bisector of BC. So somehow if you get the side bisectors of BC, C, and AB, then you basically will get the circumcenter. So now you are stuck. Now what we can do is, let's just see something more in the diagram. In this diagram, what more things that we can explore? This is the given triangle ABC. This is the point. This is the angle bisector. X is the arc midpoint. X is basically the arc midpoint. Now, what are the nice things in this diagram? What you should notice is that this point X does not depend on the choice of A. What I mean is, suppose if you have a point A prime somewhere else on the circle, and you draw the angle bisector of angle BA-C, that still goes through this point X. That also goes through this point X. So this is an important thing. So let's see. So from this diagram, what we get is, suppose there are 4 given points A, B, C, and D. What you can do is, suppose they are cyclic. Then if you construct the angle bisector of angle BAC, and if you construct the angle bisector of angle BDC, they meet on the circumcircle of triangle ABC, which is basically the arc midpoint of BC. So this is very, very useful. So now let's move on. So the next thing is, suppose, let's just try to construct. Now let's try to do things without given tool. So suppose we have four given points A, B, C, and D. Now I am taking some inspiration from this diagram. Suppose four points are marked A, B, C, and D, which are known to be cyclic. Suppose you know that given 4 points A, B, and C, A, B, C, and D, you know that these 4 points are cyclic. So what you can do is you can construct the bisector of angle BAC. Note that these lines BA and AC are not bound. I'm just drawing them to visualize things. You can draw the bisector of angle BAC. Similarly, you can draw the bisector of angle BDC, and they will meet on the midpoint of arc BC. And what you know is, and now you know is that this triangle XBC is isosceles. So you also know another thing, that if you construct the bisector of angle BXC, from here you can construct the bisector of angle BXC. This will be basically the side bisector of BC. Side bisector of BC. So now you can see, right? We have what all we started with? We started with four given points A, B, C, and D, which are known to be cyclic. Known to be cyclic. Suppose we have these 4 points which are known to be cyclic. What we saw is that we can construct this midpoint of arc BC. We can construct the side bisector of side BC. Basically, the bisector of angle BXC. Bisector of BC. So now the thing is, and there is nothing special about BC. There is nothing special about BC. What I mean is, similarly, we can construct the side bisector of CD also, right? The way in which we constructed the side bisector of BC, in the same manner we can construct the side bisector of the other sides too. And what we obviously know is they meet on the circumcenter of the circumcircle of ABCD. Side bisectors meet at O. Basically, the circumcenter of triangle circumcenter of the points A, B, C, D. So this is the next thing. This is our next lemma. And this is the most important thing. Given four marked points A, B, C, and D, which are known to be cyclic, we can construct the circumcenter of the circle ABCD. This is our second lemma. Basically, what we do, we have this 4 points A, B, C, and D. We construct the bisector of angle BAC. We construct the bisector of angle BDC, and they meet at the midpoint of arc BC. You know is that triangle BXC is isosceles. From that, you construct the angle bisector of angle BXC. In this way, you basically get the side bisector of BC. There is nothing special about BC. In the similar manner, you can construct the side bisector of CD, and they meet on the circumcenter. So in this way, our lemma 2 is proved. This is our lemma 2. Given 4 mark points A, B, C, and D, which are known to be cyclic, we can construct the circumcenter of circle ABCD. Now, the important thing is, in what does our original question say? Our original question says is that given 3 points A, B, and C, we need to construct the circumcenter. But what does this lemma say? What is the difference between this lemma and the problem? This lemma says given 4 points which are known to be cyclic, we can construct the circumcenter. But the problem says given only 3 points, we need to construct the circumcenter. So somehow we need to convert this into 3 points. So what we can do is, what we can target. So what should be our next target? Our next target should be to find a point X so that ABCX are known to be cyclic. Our next target is to find a point X so that the points A, B, C, and X are known to be cyclic. If we can find such a point X, then we can easily construct the circumcenter of triangle ABC using lemma 2, using the lemma that we proved earlier, the 4-point lemma. Now we need to get such a point X. Now this point X should not be something random, it should be something nice. So in the circumcircle of triangle ABC, what are nice points that you can get related to the angle bisectors? Let's just go back to our diagram. In this diagram, in the circumcircle of triangle ABCD, what are the nice points that you can see? This point X is nice because this is the midpoint of arc BC. This point X is nice. So let's just target this. Let's try to construct X, which is basically the midpoint of arc BC. Let's target to construct the point X so that we can construct the circumcenter of ABCX using lemma 2. Basically now our target is to find the point X. Somehow mark the point X. If we can get this point X by lemma 2, we will get that we can construct the circumcenter of triangle ABC. Now the thing is, how can we get this point X? Let's see. We have these points A, B, and C. So now we are stuck. We cannot do anything after this. We don't have much idea. So using the tool, we are not finding some idea to go ahead. Let's just go back to our original diagram and let's explore something more. So what you know is this point I, and one important thing, let's just try to explore this point X. What is exactly this point X? What do we actually want to construct? Let's see. This point X is basically, if you extend AI to meet the circumcircle of triangle ABC at X, this X is basically the midpoint of arc BC. And what are the nice things that you know about X? Basically, here is it. By incenter excenter lemma, what you know is that X is the circumcenter of triangle BIC. This is a nice thing that you know about. This is a nice thing that you know about this point X. Now, so what was the original problem? Our original problem was given 3 points A, B, and C, we wanted to construct the circumcenter of triangle ABC. We converted that into a new problem that given 3 points A, B, and C, we want to find a point X so that A, B, C, and X are cyclic. Now to find such a point X, we targeted this point X, which is the midpoint of arc BC. We are targeting this point. We want to construct this point. And what we know about this point is X is basically the circumcenter of triangle BIC. So the original problem was to construct the circumcenter of triangle ABC. The new problem is to construct the circumcenter of triangle BIC. So this may seem nothing nice because the original problem was also to construct the circumcenter. This problem, that to construct the circumcenter of triangle BIC, this is also the same problem. This is also essentially the same problem to construct the circumcenter given 3 points. So, but the nice thing about this is A, B, and C were random points. But here, the triangle BIC is not something random. Triangle I is the incenter. So you can possibly get more information about this triangle BIC. So let's explore more in the diagram. So A, B, C. Let's just try to see step by step. We have this angle bisector AI which meets this at point X. Originally, our problem was to construct center of circle ABC. Now for that we wanted X. Now we want center of circle BIC. So originally, see what approach did we follow? We basically wanted to construct a point X so that ABCX are cyclic. Now we want the circumcenter of triangle BIC. Now we want the circumcenter of triangle BIC. So we follow the same thing, right? We want the circumcenter of triangle BIC. What we can target is to find a point Y so that BIYC are known to be cyclic. If we can do this, then we can easily finish our problem. Like if we can do this, suppose we find such a point Y so that B, I, Y and C are cyclic, then we can construct the circumcenter of BIYC, which is basically X. Now the thing is, we want to find such a point Y so that B, I, C, Y are cyclic. So let's target some new point. We have these points A, B and C. We have this triangle BIC. So let's try to explore more in the diagram. Can you think of some nice point? Initially we thought about the point X so that A, B, C and X were cyclic. Can you think some nice point Y so that B, I, C, Y are cyclic? Now here comes. Okay, now I am giving the solution. Pause for a minute and think about this. So what is the nice point? See, we got this information about X from the incenter-excenter lemma. The incenter-excenter lemma does not give you only that X is the circumcenter of triangle BIC. The incenter-excenter lemma gives you something more, which is the excenter of triangle BAC, the A excenter. This also lies on the bisector of angle BAC, and you know by incenter-excenter lemma is that BIIAC are cyclic. So originally we had ABC, we wanted the point X. Now we have BIC. If we can somehow get this point IA, then we can construct the circumcenter of triangle BIC. Now, so we know BIIAC are known to be cyclic. Now, how can we get IA? How can we get IA? If you see, IA lies on the interior bisector of angle ABC. But the problem is IA is the exterior, IA is the excenter. The thing is, you can construct like IA lies on the exterior bisector of angle ABC. This you all know. IA lies on the exterior bisector of angle ABC. But the problem is you cannot construct exterior bisectors. You can only construct interior bisectors. So just think on this way. Suppose you have some point Y on this extended line AB. Suppose you have some point Y on this extended Y AB. On this extended line AB. This exterior bisector of triangle ABC is basically the interior bisector is basically the interior bisector of angle YBC. So somehow if you get a point Y on the line AB, then you can easily construct the bisector of BIA, the bisector of YBC. The thing is, suppose you somehow want to get the point Y. For this, you want the line AB, but the line AB is not given. So how we can proceed? So this is the problem. We initially had 3 points A, B, and C. The line AB is not given. If it was given, suppose, and in some or the other way, suppose we constructed a line which intersects AB at some point Y, then we could have easily constructed this exterior bisector of ABC, which is basically the interior bisector of YBC, and you could have got the eccentric. So now the new problem is to get a point on the line AB extended. Now the new problem is to get a point on the line AB. Also, we want the line AB. So the new problem is A, B, and C. Given A, B, and C, can we construct the line AB? It obviously looks challenging. So let's just try to play around. Let's just try to play around and see what all we can do. Let's try to finish the problem. So given 3 points A, B, and C, what you can do is we can construct the interior bisector of angle ABC. We can construct the interior bisector of angle ACB. They meet at some point I, which is basically the incenter of angle ABC. Now what you know is the line AB, BC, and C are not given. So you know is you cannot construct. So you don't know how to get the eccentric of triangle ABC. But now the thing is, our problem is to get the center of triangle BIC. For that, we somehow need a point on the circumcircle of BIC. So basically, we are interested in the eccentre of triangle BIC, not triangle ABC. And what is the nice thing about triangle BIC? In triangle BIC, we have the lines BI and CI marked. These lines BI and CI are marked. This is the nice thing about triangle BIC. In triangle ABC, the lines were not marked, but we constructed the angle bisectors, so the lines BI and CI are already known to us. So what you can do now is, can you get a point on this line BI? Can you get a point on this extended line BI? If you can somehow get a point on this extended line BI, then you will be basically you can basically construct the eccentre of triangle BIC. Now let's try to think. So we have these 3 points A, B, and C. We have this interior bisectors. This is LABC. This is LACB. They meet at some point I. Now, so we want a point Y on this line. Think about this for some time. So pause the video and think about this. So how we can get such a point Y is, look at this. Construct the bisector of angle CAI. Construct the bisector of angle CAI. This gives you a point Y on the extended segment BI, right? You can mark the bisectors of, this is basically the bisector of angle IAC, and the intersection of this with the bisector of angle BAC gives you such a point Y, which lies on the extended line BI. And now what you know what to do. So let's finish this. So we have these 3 points A, B, and C. What we do is, these lines AB, BC, C are not given. We construct the bisector of angle ABC. We construct the bisector of angle ACB. They meet at a point I. and we know we have constructed a point y which lies on the extended segment AB. Y lying on extended BI. We have constructed such a point y. How did we construct? Y is basically the intersection of the bisector of IAC and the bisector of ABC. So now what you can do is, our main motive was to construct the x center. So what you can do is construct the bisector of angle YIC and construct the bisector of angle IBC. And you can mark their intersection. Suppose this is Z. Suppose this is IB. And what you know is IB is the B excenter of triangle BIC. And we already know we can construct incenters of three given points. BIC is a triangle and we know how to construct the incenter. Suppose it is Z. We can easily construct the incenter of triangle BIC by marking the interior bisectors. So we have this point Z and we have this point IB. So we have already marked these points Z, IC and IB, and by incenter excenter lemma we know that these are known to be cyclic. So using lemma 3, what you can claim is that you can construct the center of this circle. You can construct the center of this circle. So let's see. We have this 3 points A, B and C. This is we first constructed the bisectors of ABC, ACB, and they meet at I. We constructed a point Y on this line. We constructed this excenter. We mark this point Y. We constructed the excenter. We can also construct the incenter, and we know Z, I, IB, C are cyclic. So what you know is that you can construct the center of the circle. Construct the center of circle I, Z, C, IB, lemma 2. I think we had one lemma only. Lemma 2. So now we have the center of IZ, CIB. Suppose this is P. What we know about P is the midpoint of arc IC in the circumcircle of BIC. P is the midpoint of arc IC in the circumcircle of BIC. Basically what we know is that BIPC are known to be cyclic. BIPC are known to be cyclic. What does this mean? So let's finish it. We have this A, B, C. We have this point I and we have this point P. We know BIPC are cyclic. So we can construct center of circle BIPC. And what you know is that the center of circle BIPC is basically the center of circle BIC, which is basically the point X. And this is what we wanted. So X is basically the point that we wanted, and we have got this point X. Now what you know is that A, B, C and X are cyclic. So you can construct the circumcenter of triangle ABC. So let's have a quick summary of the problem. So what did we do is that first we proved that given 4 points A, B, C and D, which are known to be cyclic, we can construct center. We can construct center. Then what we did was, given 3 points ABC, we wanted to find the midpoint of arc BC. What did we do was we constructed the bisector of angle ABC. We constructed the bisector of angle ACB. Then we constructed a point Y on this line, Y on this bisector of ABC. How did we get this Y? We got this Y by constructing LIAC. We got Y. After getting this Y, we basically drew the bisector of YIC and IBC. Those gave us the excenter of BIC, and we also know how to construct the incenter of BIC. And from here we know I, P, C and Z are known to be cyclic. So using the lemma, using our main lemma, we can construct the center of I, P, C and Z. Suppose that is Q. So we have these points A, B and C. We have constructed the point Q. Q is basically the midpoint of arc IC in circumcircle of triangle BIC, which means BIQ and C are cyclic. So BIQ and C are cyclic, so we can construct the center of the circumcircle of BIQC. Suppose that is point X, and you know the center of circle BIQC is basically the circumcenter of BIC. So we got the point X. Now what we know is X is the midpoint of arc BC. X is the midpoint of arc BC. So you know A, B, C, X are cyclic. This means you can construct the circumcenter of triangle ABC using lemma, using our main lemma. So this was the problem.